Today's lesson is on section 10.3, and we're working our way through the conic sections. Yesterday we went in depth on parabolas. We looked at the equation of the parabolas. We talked about two important features, entities that were used in creating the parabolas, the focus and the directrix. And now today we're going to shift our attention to equations and graphs of circles. So here we are again using this picture, this little illustration of how the circle is created by taking this flat surface called a plane and cutting through the cone with no angle at all, just going straight across, and you can see how the circle then would be formed. So it's my goal today to introduce you and have you practice the standard form circle equation, and then at the end of the lesson we'll take a quick look at how to graph these equations of circles. What I did in class today is we worked our way into the equation of a circle by drawing on some past information. So I asked the class, what is this red line that extends from the center out to really any point on the circle? And pretty much every class was able to tell me successfully that that's known as the radius of the circle. And then I asked a little more challenging question that very few people knew the answer to, and that was, well, how would I find this distance from the center, this point 32, to this point? I just identified it as xy, it could be any point. How would I find that distance? In other words, what actually is the radius of the circle? And in Algebra 1, and some people are taking geometry currently, you were introduced to what is known as the distance formula. And that allows us to find the distance between 2 points, any 2 points on the coordinate plane. And maybe you remember it once you see it. Once I started writing it up, I heard a lot of people say, oh yeah, I remember that. Okay? Well, that is the distance formula, the difference between the x's squared added to the difference between the y's squared of the 2 points that you want to find the distance between. Well, since we're talking about a circle, and since we're trying to find out what this radius is of the circle, then I told the class, well, let's just change this d into r, because really that's what we're finding. We're finding the radius of this circle. And using a little algebra, if I wanted to undo taking the square root of this right side of the equation, I would square both sides. And that leaves me with r squared, and I no longer have the radical on the right side of the equation. And then I'm going to use actual numbers from this just as an illustration. I'm going to do x minus the x coordinate of this center, which is 3 squared. And then I'm going to do y minus the y coordinate of this center squared. And what we have here is actually the form. I would need to know exactly what this number r squared is, but what I've done here is I showed the class that the standard form equation for a circle is really a derivative, or it flows naturally out of the distance formula. Because as you can see here on my next slide, this is the official standard form circle equation. And this is what we're going to be using quite a bit in this lesson. So x minus h, and h represents the x coordinate of the center of the circle, plus y minus k, k represents the y coordinate of the center. Both of those quantities squared, as you can see. And that equals radius squared, where the number r, radius, would be obviously raised to the second power. Okay, so hopefully you have this down in your notes, and you're going to get a lot of practice. Hopefully you're going to be very familiar with this standard form circle equation by the time we're finished practicing today's assignment. So let's get specific to the assignment. The first block of problems are going to ask you to do this. You have an equation. We need an equation that has, this circle has a center at the origin for our first example, and this circle has a radius of 6. Well, I just want to rehearse again your standard form circle equation. Okay. All right, so this number that plugs in for h in standard form should be the x-coordinate of the center. So we're going to let h be replaced with 0. This number k should be the y-coordinate of the center. So I'm going to let k be replaced with 0. R, in this case, radius, is 6. So r squared would be 36. And I told the class today, all the classes, if you came into class tomorrow with this as your answer to this particular homework problem, I would say for tomorrow, that's okay, no problem. But I want you to understand that this really is a better way of writing this particular equation when the center of the circle is at the origin. Because x minus 0 just simplifies into x. And same thing for y minus 0, it becomes y. So for tomorrow, if you forget, this would be considered good, but this would be considered best. And so if you should happen to show up tomorrow with this, I'm going to say no problem, but I'm going to steer you for future reference to try to remember to always do it this way. All right, so let's take a look at number 2. We have this circle that has a center at 4, 0. So once again, my h number in the standard form is going to be 4 squared. Y, just like up here, the k value, the y-coordinate of the center is 0. So I basically have y minus 0 like we had in this previous problem. So that's just going to produce y squared. And then radius squared, 4 squared would be 16. So that would be my answer for number 2. For number 3, really the time that you have to kind of be careful with the circle equations, will be times like this. Remember, our equation is x minus h squared. Well, h in this case is negative 2. So it literally would be like this. Well, we know that when you subtract a negative number, that's the same thing as addition. So just be careful. A lot of the people today were saying, isn't it really just the opposite? And that's true. It does end up being just the opposite of the way it looks in your equation. And so we're going to let this equal radius squared. 3 squared would be 9. So that would be my answer for number 3. All right. Let's move on to some more examples in 9 through 16. It's really the same process, but now we're going to word it in terms of translations. Remember, a translation is just taking a graph and picking it up and relocating it. So when you're looking at this standard form, not only does h and k represent the center of the circle, but you can also, it's no problem, you're not hurting anything by also thinking of them as, in this case, h being your movement horizontally. So if you're going to move to the right with the graph, then h would be a positive number. And if you're going to move to the left, then h would be a negative number. All right? So the number k stands for, or it will be replaced with whatever movement is done vertically. So an upward move means that k has to be a positive number. A downward move means that k has to be a negative number. So let's see how this works. We're given, as you can see, a circle that is centered at the origin. Okay, notice how this is our circle centered at the origin. H and k are both 0. Well, if we want to take that circle and move it 2 places right, let's just stay with that for just a second. The movement 2 places right, right is horizontal, right is also positive. So that means that in this particular case, the h number, the literal h number, is 2. So when I plug into my equation, I'm replacing h with 2. Okay. Now, let's take care of the vertical movement. Our vertical move is 1 unit down. Well, down is a negative direction. So you can think of this as being -1 substituted in for k. Well, if you put -1 into this existing, equation for k, there's already subtraction in this equation. When you subtract -1, you end up with addition. Okay, so that ends up being my final answer for this number 4 problem. All right, here's another circle, center at the origin. We're going to shift it 4 units left. Well, left obviously is a horizontal movement, and it's actually, since we're going to the left, this should be -4 plugged in for h. Well, if I replace this h with -4 to represent a left move, and I subtract -4, then I'm going to end up with x plus 4 squared. And since I did not do any vertical movement, then the y variable is not affected at all. And then, of course, I'm going to let this equal 25. So that would be my answer for problem number 5. All right. On 19 through 26, you will be supplied with the complete circle equation. It will be your job to pick out the center and the radius. So once again, remember this is x minus h squared plus y minus k squared. Okay, that's our standard form. Well, if we need the center, remember the center is represented by the variables h and k. Well, it looks like h in this particular equation is the number 16. And k in this equation, since we're adding, then k must have been -9. So I guess you really are thinking opposite here. So my center is the point 16, -9. The radius, well, remember when you're looking at the standard form, this is equal to r squared. Well, if I want to know what radius is, or just plain r, I need to find the square root of this number. And so the square root of 144 is 12. So that would be my answer to this example. The center is 16, -9, radius 12. By the way, it sometimes happens, and I think it's going to happen one time on your homework, where you may be given an equation where the number does not have a perfect square root, like, let's say 24. 24 is not a perfect square number, so obviously there's no perfect square root. So what I want you to do in cases like this is don't give me the calculator decimal form of the square root of 24. I want you to give me the simplified radical form of the square root of 24. So when you say what the radius is, if this were your problem, you would say 2 times the square root of 6. Okay, so just keep that in mind. I believe it only comes up one time in the assignment for the problems that you have to do. Okay, graphing circles is really pretty simple. I need two things. I need the center and I need the radius. And then from there, it's pretty easy to sketch the graph. So hopefully you know by now that the center of this circle is going to be -1, that's h, and +3. That's K. So let's plot that center. The radius, this represents r squared. So r is just 5, the square root of 25. So to graph this circle, I'm going to start at this center, and I'm going to go out 5 units in 4 different directions. Up, down, left, and right. And then I'm just going to use those 4 dots as guides. You don't have to do anything fancy. I do want you to do your best to, and that's not a very good circle, but I think you get the idea. Sometimes these end up looking like diamonds or just weird shapes, but just something like that. Don't take a compass or anything and try to draw an exact circle. It's just a rough sketch, but mainly I'm looking to see if these are correct, and then we'll just freehand around those dots. All right, so I didn't do a lot of these examples because these are pretty easy. If the radius is really huge and it's impossible to do the circle, maybe you end up with a radius that's here, or center that's here, and it's impossible to draw the circle on the graph section, then you want to change your units so that you can make it fit. Okay, I'll just have one more example, and that will conclude this lesson. I thought I would help you with the very last problem on the assignment because it's a little different than the rest. The thing that makes this different is you're supposed to write the equation for this circle. You don't have to graph it. You just have to come up with the equation. But instead of giving you center and radius, they're giving you the center and then another point on the circle. Well, we know that all the points on the circle are the same distance away from the center. So we just need to find out what that distance is, and that will be our radius. Well, remember at the beginning of our lesson, we used the distance formula to find out what the radius of a circle is. So here's my distance formula. It's the difference between the x coordinates. We'll just call this x and this x1. The difference between the x's squared and the difference between the y's squared. Okay, so 6 minus 2 is 4, and 4 squared is 16, plus 4 minus 1 is 3, 3 squared is 9. We have the square root of 25, which is 5. Well, now that I know I was given the center, now I know the radius, it should be pretty easy to write this equation. X minus the x coordinate squared, that's h, plus y minus the y coordinate, that's our k, equals r squared, which is 25. So just wanted to show you this example. It's very much like your number 48, but it's presented a little differently, so thought I would give you a little heads up on that one. All right, that's the assignment, and I'll be glad to help you out with any questions, and we'll see how you did on these tomorrow.